Here's the problem we started in class, but I'm going to graph the first part, the first sentence of it now. So we were looking at this portion and we had written down the givens, but I'm going to have to write them again. So um, bear with me here. So we had written that the initial velocity is 0 because it starts from rest. We know the acceleration is 10 meters per second squared, or 10 meters per second every second. And this part where it's accelerating lasts for 4 seconds. That's what we know from the first part. And we're wanting to graph both a position time graph and a velocity time graph. So for the position time graph, if we were making a chart, we're really only going to put a couple of points on this. Let's also add that we're going to start the ice sled at position 0. Okay, so we're going to plot 0, 0 right away. Since they don't tell you otherwise, you're allowed to do that. So now we need to find the position of the sled after 4 seconds though. And so what we're looking for is df. And if you look at your equation sheet, since we know the initial velocity, the acceleration, and the time, the equation that will help us find df the easiest is to use the long equation on there. Actually, it would help if I move this graph down here. Hold on. Let's try doing that. Oops. So let's solve that, and we will get the position after 4 seconds. So then I'm going to plug in my points. I know it's at 0 meters. This, because it begins at 0 meters per second, really this second term is going to go away. 0 times 4 is just 0. And then plugging in all my information here. Oops. 4, squared. That's in seconds. So then when I do the math, I'm going to have 0 meters plus, seconds cancel here, 0 meters again, plus 1/2 times 10, that's 5, 4 squared, 16. This comes out to be 80 with 3 sig figs, I believe. And then this is in seconds squared, this is seconds squared. So I end up with meters, which is good. So then I'm going to have 80 meters here. So that's good. I have 2 points I can plot. And I messed up my first point, so let's try replotting my 2 points. So I have 0, 0, and then let's add our times on here. I tried to spread out the seconds, but the positions are kind of crammed together. So we have the y-axis going by 20 meters. Okay. So then I'm plotting 4, 80. And so then when I go to draw the curve or the line between these points, it would help to have more points, okay? But if I'm being lazy, which I am today, I'm just going to go based off of the shape I expect this graph to have. And when something is speeding up, which this sled is, it is going to start off with not a very steep slope. And then it is going to get steeper and steeper. And it is having a positive velocity, okay, as it goes, because it's got a positive acceleration and it started from rest, so it's going to keep adding positive velocities. So I want it to start off with 0 slope and then gradually, that looks kind of funky, but I want it to be curved, maybe that's better, and like the right side of a U. Okay? Maybe you'll do better on your paper. All right. So, and then the second part of the problem is where it just goes at a constant speed and then it would extend with like a diagonal line after this. But in this time, we're not going to finish this problem. We're going to leave it at that. Okay, then it wants us to find a velocity time graph. So let's talk about that part. When we're plotting velocities, we're going to need to know what velocity it is going at different points in time. So I'm going to, need to start with time. So I'm going to have time and velocity now. And I know that it began from rest, so I'm still starting with 0, 0. That's not always the case, but it is this time. And so now I need to know what is the velocity at 4 seconds. Now, you can do this by using the slope because you know that acceleration is 10 meters per second squared, or in other words, the sled is gaining 10 meters per second every second. So I could go up 10 over 1, up 10 over 1, like that, right? Or if you'd rather do it with an equation, let's write that out. You could use, for example, this one's easy for us because we're looking for the final velocity. So we could plug in 0 plus 10 times 4 seconds. Sorry, I'm running out of space here. So then we'll have 40 meters per second as our point that we're plotting here. So again, if we extend the time out here, here's 4 seconds, and then the y-axis is going like very gradually up, 10, 15, 20, 25, 30, 35, way up here is 40. So I need to go over 4 up to 40. Now the shape between these 2 points, okay, but we know this is a constant acceleration, meaning constant slope. So since the slope is just the number 10, I could very easily plot points here because I know it's going up 10, and this makes a line, right? So then whenever the position time graph is a parabola, the velocity time graph needs to be a diagonal line. Okay.